Hey, welcome to video 15 in our van build series. Today, we're going to tackle the first part of our van's electrical, the charging system. When I finished the solar roof rack, I figured I was going right on to wiring. In reality, there's a half dozen little interdependent projects that need to be tackled first, starting with basic cabinetry. Where and how are we going to mount all of these electrical components? In this video, we're going to cover everything from plugging in the solar panels to routing wires, mounting the charge controller and related hardware, connecting the vehicle's 12-volt lead-acid battery, as well as the camper's 12-volt lithium battery. We're going to look at wiring schematics, basic cabinetry and hardware, and we won't stop until the system works. Let's get started. For me, it quickly became abundantly clear I first need a place to put this stuff. I knew I wanted it on the left side of the van under the bed, so I started by making a template of the area out of cardboard. I started by placing large pieces of cardboard and then slowly started filling in the gaps with smaller pieces, taping the cardstock in place. Well, the tape didn't hold. So I used some temporary 1/4 inch bolts with large 1-inch washers to firmly hold the cardstock in place so I could trace the form onto some recycled 1/2-inch spruce plywood. The 1/2-inch plywood was previously part of a shipping container, a great reuse of material. Okay, well that's a good start. The template worked just fantastic, and of course it's a exact copy of this side, so I made a second one, and they fit like a glove on both sides. So game plan here is now to focus on this side and start working on the electrical, and this here likely it'll end up being a water tank or something over top of the wheel well there. I'm a big fan of bolts versus screws. For this reason, I have chosen to install rivet nuts to mount the plywood to the wall of the van. I also need to make use of the wheel well area, so I'll need to quickly make a box to cover the wheel and to make this area useful. What is important to draw attention to here is that I made the shelf wider than the wheel well to accommodate the components I have planned for the shelf. I'll be mounting both the 200 amp hour lithium battery as well as the 2000 watt power inverter on this shelf. Sticking with my bolts versus screws philosophy, I also wanted to make extensive use of blind nuts. Blind nuts will bite into the backside of the plywood, allowing me to use bolts to hold the components in place. Technically, they're called T-nuts. Here's a great shot of me seating one of the T-nuts. With the board and the shelf cut to size, we used some wood filler to clean up the recycled plywood and quickly primed it. The next thing I needed to do was to make a bit of a tray to hold the battery in place on the shelf. I used some leftover cedar from a fencing project. Here I have assembled both the plywood wall and the wheel well shelf outside of the van. You can see we have used a fair bit of wood filler to improve the smoothness of the plywood. Also note the 5 holes down in the bottom left. That is a cabin vent area on the Ram Promaster. Air needs to be able to escape the vehicle here. My goal within this video was to just tackle the charging system, and although that's exactly what I'm doing, you do have to plan for the complete electrical system. So I've removed some of the components right now just to show you where I'm at. So from the solar panel, which will be up here on the roof, there'll be a cable coming down inside the van, probably popping through the plywood here and going to this isolation switch. And so I can disengage the entire solar panels from the charge controller, just as simple as that. Cable will be coming out of here and going into the charge controller. So that's the first and primary source of electricity generation, the solar panels. The second one is going to be coming through the floor of the van,
and coming up around here and going through this breaker and into the DC to DC. So this will be from the van starter battery into the charge controller. So we'll be, on this side here is coming from the solar, and on this side here it's coming from the vehicle's starter battery. Coming out the top here, power line is going to be going through here into this breaker to protect the line, and this power line will be going over to the red terminal. So as I mentioned earlier, that is the charge portion of this. To continue from there, the red, this line coming from here through this breaker, coming from here over to there, is actually going to be connected to this one as well. So the line is going to be coming up to here, but we'll leave this side out of it for a minute. Then the second line is going to be coming over to there. So essentially this is one piece of copper all the way through. However, power goes both ways. So when you draw power, that's this 12-volt panel here with all the fuses, it'll come back the other way through the same line into here, out here, and into here. Ground side, sorry, positive over to here and down into here. These are grounds. So that's essentially it. I know it's a step further than what I was talking about doing, but the charging portion is being looked after, solar and DC, and I'll spend more time talking about where the cables are coming from and so forth later. Going through the charge controller, through this line breaker into the battery, but it will be connected right at this location. So later we can bring the power across this way into here. So the big piece of the pie that's missing here is this shelf area that I've set aside for our inverter. And this is a 2000 watt inverter, so it'll run our microwave, our Instapot, toaster if you need it, that kind of thing. And as you can see, very quickly this area fills up. So this is why I was saying I had to do an awful lot of planning just to make sure I had the real estate for the components I needed. So I'm going to swing around the backside now and show you some of the how I'm attaching these pieces. On the backside now, you can see that I'm making extensive use of blind nuts. Actually, that's not the correct term. I think they're called T-nuts. And this, of course, allows me to use bolts instead of screws. I'll be cutting these to length prior to actually installing it in the van, but you can see I've used them everywhere. Just going to quickly share with you one of the challenges I've had with mounting this equipment. This all looks straightforward. The battery goes behind here. I currently don't have it in place. I had planned this area all along for mounting the 2000 watt inverter. And I'm disappointed actually with Renogy's design on the mounting for this. They have the flanges down here for bolting or screwing into whatever material you have. The problem is if you hold the screwdriver right against it, you can't actually get at the screws. You have to be going out on an angle. That's not a big deal unless, of course, you're mounting it on a shelf in the back of a van where you're right against the actual wall of the van. So on this side here, I can't physically get in there to reach, i.e. I can't go in here and pull out to get at the screw. I simply can't get at it. So I came up with a plan B. Here it is. I built a shelf out of 1/4-inch birch. This is wood left over from when I made the shower base. And by doing that, the unit itself is riveted from the backside through the birch. And now I've got lots of access to easy mounting locations. Yeah, I'll show you close up here. Just A4 rivets all the way through. Super strong, easy to mount. And now I can just drop it in and go right through the wall here. There it is. And into some T-nuts. And it's permanently mounted.
At this point, I changed my focus to tying down the battery. Here you can see I've cut a slot in the plywood to make space for the belt. This is a canvas web belt with a double D-ring. Moving to the front of the unit, I cut a small slot in the plywood just below the battery, super secure and not over-engineered. Here I'm adding some flux to remove oxide film. And I used a torch far faster than a soldering iron on this gauge of wire. However, not something I do regularly, so it took me 4 or 5 ends before I got proficient at it.
Okay, I have some of the wiring done here. I'm going to check as I go here. I'm going to check continuity in this line, and this line. And I'm also going to check the function of the breakers. So I have just using some vice grips here to clamp a lead up to this area here. You can see the ohms meter there. We've got a good connection. So now I'm going to check all the way down through here, right back to the charge controller. We're looking at this. We've got a good connection. And I can kill the breaker to the fuse box, and it works. And I reset it, and I can also kill the breaker downstream from the charge controller, and it works. So far, so good.
A little more soldering, and now I have a positive line connected from the charge controller to 3 breakers, the battery, and the fuse box. Tomorrow, I'm going to start running the 6-gauge wire from the van battery all the way to the back of the vehicle. Let's see how that goes.
This morning, I'm working on DC to DC charging. So I'm just working on the routing of the wire. I've pulled out this wheel well area, and I'm going to be using a channel here in order to run the wire down to the back. So essentially, I've gone, let's just see if I can show you here. I've gone underneath again into this area. You may have seen me cleaning this area in a previous video. And this is the 6-gauge wire that I'm using right here. And I have it running just underneath the starter cable. I have chosen not to go downstream of this fuse. I don't want to be using this fuse for more than what it's used for. I believe this is the starter cable right here. So I'm actually going above it. And it doesn't mean that it's not fused. I've actually got it fused at the other end, but I'm going to be connecting right on this terminal here, and then fusing it at the other end on the electrical board. So just getting started on this. Prior to playing in this area, I did disconnect the ground, so it's currently disconnected. And I'm going to tighten this down and start routing the wiring. Okay, we're making a little bit more progress. I have the 6-gauge wire, of course, here, and underneath here I'm entering it inside some 1/2 inch loom, and I'm taking a spare wire protector down the side here, and again I'm just in the wheel well area, then exiting here, grabbing around the side here and working it up into this area, and I'll swing around the other side to show you what's happening from there. So I have a couple options here. Yeah, I'll let you know if the first one doesn't work out. There's a lot of room in here. This is the seat belt assembly. I've removed this entire this section here. There's a lot of room in here. It'd be very easy for me to enter in from the side here, go in behind here, and then drill out there. I might end up doing that. Right now, I'm actually thinking about just running the channel directly underneath here and then down. Investigate this a little bit further, and I'm either going to be coming directly underneath here, or I'm going to be drilling into this and then out and coming down and so forth. Well, I've got the DC to DC 6-gauge cable from the van starter battery all the way back to the back here now, well protected. And I've just reconnected the 12-volt terminal on the battery, and nothing's blown up so far. And I've got this connected to the ground, and let's check a positive. And we've got, looks like 12 volts. So it's working well, it would appear. We've got 12 volts from the car battery at the back of the van.
Here I'm plugging in Renogy's D+ ignition wire into the charge controller. On the wiring diagram that I received from Renogy, it's the green wire. The interior fuse panel is part of the body control module and is located on the driver's side under the instrument panel. Looking at my owner's manual, cavity F31 is a 5 amp beige fuse used for the interior. It is marked INT/A. What the Renogy charge controller needs is a signal that says the engine is running. So I need something that is live and shows 12 volts when the ignition is on. I'm not drawing any current here. I'm looking for a signal. I'm just looking for a signal. So I popped in a fuse doubler to check for power when the engine is running.
All right, and ground it. You got 12 volts. Okay, you turn the ignition off. You test it. It's dead, so that is a good circuit to use. So this is positive, and we're doing it in parallel, so I need to connect all the positives together. So if I do this right, this is positive. This will bring, I'll plug in the second positive here, that'll reduce it to 1, and then I'll do it again to bring it down, all three down to just 1. So this should just clip in. Wow, that's it. Okay, and we'll do the same with the negative. So, like this. That's it. This one here is positive. You can't see it from there, but it is. So, and this one is positive. So I'm going to plug into here. All right. So I have two positives down into one, and negative, and negative. Okay, I'm down to a single positive and a single negative. I go over to the next panel. All right, so I need to bring this one. How do I do this now? So this is negative, and I need to bring another negative in. So I've got to get down to one negative. So I think this one has to go like this. Okay, and the positive, same as the same thing, like this. Oh, this is gonna be tight. So that's connected. I now have one positive and one negative, and there is no extra space at all there.
Renogy's cable entry housing is far too wide to mount securely on the corrugated Ram Promaster roof. I have to fix this.
Okay, so I've got two holes now. Oh, let's put positive in this one and negative in that one.
I used 100% silicon to adhere the cable entry housing to the roof. I added a can of paint for weight while it's set overnight.
Well, we're a day later now. This is really nice and firm attached to the roof. I used silicon to attach it. What I didn't show earlier was when I cut this in half in order to reduce its width, I removed about a 3/8 of an inch, just a guess, from the center. I brought it down to the width of this, whatever the panels are on the top of the Ram Promaster. I think they're 7 or 7.5 centimeters. And then I glued the two halves together just using hot glue. Used some masking tape and then put down some silicone to cover the seam. So this worked really well. I'm not done with this yet though. I want to put down some lap seal, that big white stuff that you put around, the same stuff I used when I did the Max Air fan, that white stuff around the side here. And then this is done. And then of course I'll be threading in these two friction nuts which squeeze down on this and make the entire thing watertight. That looks pretty good.
With the solar panel wiring complete, I can mount the panels to my roof. Pretty simple and clean installation. I'm done with the roof, time to move inside.
Okay, this took a little bit longer than I thought. Here's the two wires coming from the solar panel. I put them inside a loom to protect them and then entered the frame right here. I did have to remove some of the insulation I put in earlier just along the frame rails in order to make the passage of this material a little bit easier. And the only tight spot was just inside here, but I've got it all the way through. So it goes right down to the end. Then I removed all the panels from this end, from this corner, and you can see my my loom right here going all the way down here and coming out just behind where the electrical is going to be. So this power here is solar, and this power is DC to DC. So that completes the running of the wire, the two wires for my charging system. So I'm now going to do some last minute stuff in this area and then be able to start mounting the actual equipment. Regarding the gauge of the wires, I'll talk about that in the next one. I just wanted to share right now that I've done a fair bit of prep work in order to move this plywood into place and not have to remove it later, knock on wood. So I'm sure there's something I haven't thought of, but that's just a little bit of the work I've done in the background to prepare for the install, which I'm going to do right now. Fairly neat.
There were a number of different wire terminals I needed for this project. I used 6-gauge almost everywhere, with the exceptions being the cable that came with the Renogy solar panels, which was a thinner 10-gauge.
Well, we have it turned on for the first time. And at the top here, we can see we have a blue light, which is the battery type indicator. And I believe I have it set correctly. Blue is for lithium. The one below that is the service battery indicator. It is yellow, which means battery voltage is normal. And now I'm going to go live with the solar panels for the first time. Turn it on. And we're looking for power to come in from the solar panel. We know that we need 15 watts for 10 seconds, 15 watts or more for 10 seconds in order for this to go live. And look at that, we're now charging from the solar. Let's see, red for solar says bulk charge. So we have a bulk charge going on right now from the solar. And now I'm going to connect to the vehicle, the van's alternator. See what happens? Awesome. So red is on, which means the alternator is charging the service battery. So we have the alternator charging the service battery. We have the solar panel charging the service battery. The battery itself is in a steady state and it's a lithium. Everything is working.